Hello, everyone. Yes. Oh, I just hopefully the Twitch app now works. Oh, okay, I'm gonna go to Stream Manager. Yeah, need someone to chime in. Hello? Need people to chime in. Yes. Snowy Thursday today. That's good. Need someone to chime in. We got 5 viewers. Hello? Hold on. Let me type this in. Let me see if this works. Ah, hello. Oh dear, not this app again. Alright. Failing. Things damn failing on me again. Why is it doing that? The Twitch app. Alright, hey Tilted. Hey BS Wilson. Hi. Yeah, you gotta restart the damn app these days on Twitch to actually get that. Alright. Mic check, audio check, check 1, 2. How do we sound? Very important. Also, now it's time for the light. Lighting is important. I'm gonna say hello. Oops. Alright. Check. Audio check, mic check, video check, loud and clear. Alright. Hello everyone. Yeah, we're gonna need all the time that we're gonna need all the time today. Hello everyone, I'm Ming Chow. I'm teaching professor at Tufts University, and this is Introduction to Security. And today, yeah, now I see the message. Yeah, I do see messages in the chat. Okay, we can't continue without chat, you know? So today is going. Yeah, I had to refresh too. Today we're going to do distributed denial of service attack, DDoS, and also, to make a long story short, how to actually take down the internet. No, I'm not kidding. No, not kidding. Like, how you take down the internet. Really? Yeah. Yep. With code examples and Python. Yeah, we're gonna do it today. We're gonna need all the time in the world. So we're gonna use Wireshark again just to take a look at some stuff that happens under the hood. And I said Python, right? Yes, we're actually going to do a little bit of Python programming today. Yes, Python is a lot of people's friends. But first and foremost, let's get to some vocabulary. Yes, on what is a DDoS attack or distributed denial of service. I think everyone here has been involved or have seen a distributed denial of service attack in one way, shape, or form. Usually it's bad. When you don't have access to a resource that you generally have. For example, on the first day of every month, if anyone tried to buy Legos um, online, basically you can't even get onto the website. I think as of recent they put in a queue, or if you ever tried to get the PlayStation 5 or the new Nvidia cards online, you probably crashed the website. Mm-hmm. Yeah, you probably crashed the website. So those are some inadvertent examples of distributed denial of service attack. Yeah, there is a sale. The first day of each month for Legos is when like the new batch of stuff comes out. And people like Legos. A lot of people now use Legos for investment. They don't even like buy the set. They don't even open them. Oh yeah, first day of every month there's like a new batch of stuff coming out. Um, Hearing that there is new Simpsons stuff that may be coming out on Legos in March too, like the Krusty Burger. So here is, and I love Cloudflare in terms of their documentation and resources because they give a pretty good overview of basic terminologies and concepts. So what is a DDoS attack? So DDoS attacks are still happening every second today, but a distributed denial of service attack is, to make a long story short, is usually is quote unquote an attempt to disrupt the normal traffic service or network by overwhelming the target to render it inoperable. Okay, usually how now here's what the first D in DDoS, distributed, really means. By utilizing multiple compromised, usually compromised computers, infected with malware systems as sources of attack traffic. Okay, from a high level, DDoS attack is like an unexpected traffic jam clogging up a highway, preventing regular traffic from arriving at its destination. Okay, what determines how many users can visit at a time? How can companies plan for it? So, interesting. This is a very hard problem. This is not an easy problem at all. So, if you ever install a general, let's say you open up a web server on your computer, well, you install like Nginx or Apache. I think the number for the longest time for years have been usually like 2,000 users, like simultaneous on a very small box. Somewhere around that line. Somewhere along that line. So that's a number that I keep in my head all the time. Probably the number has gone up a lot. But yeah, I mean, 2,000, 3,000 users on a very small, tiny box on a very small web server. So your second question is, how can companies plan for it to try to avoid DDoS attack? Yeah, that is actually a big question, and companies like eBay, Amazon, uh, e-commerce shops do all the time. So a lot of companies, I'm not going to name names, what they do is, for example, during the holiday season, because holiday season in the last part of the year, they know that there's going to be a lot more traffic, a lot more people going to be buying stuff online. So the way that they actually plan for it is they actually add more computers, add more servers to handle the load. And that can be done relatively easy these days with the cloud. So the idea of basically throwing more resources and computational resources up to handle the traffic. And then after the holidays, they go back to quote unquote, they take down the resources that were used to handle the traffic load. So that's how companies can plan for it. So now you know what DDoS is, uh, how a distributed denial of service, like what it is. But how does a DDoS really work? How does it work these days? So I want to give you, and this is one of my favorite pieces I have, I use all the time, and how DDoS is distributed denial of service attack are done these days. This is a fantastic article written in 2012, and it's still relevant up to this day. And the idea is this thing called an amplification attack. Okay, so Cloudflare, what they do is they go and mitigate many DDoS attacks for companies, institutions, you name it. Um, Amplification attacks, what they are, how you amplify a distributed denial of service attack is, an attacker magnifies the amount of bandwidth that they can target at a potential victim. Now, this is a good, this is a really good article because it shows you what it was like back in the days, a brief history of time, and what it does happen now. So imagine if you are an attacker and you control a botnet capable of sending out 100 megabits per second of traffic. Now, a botnet is a small net, is usually is a network of compromised computers, usually hit with like some malware, ransomware, you name it. Okay, so, what's the size of this botnet? I mean, that varies. I mean, it could be like dozens and dozens of computers, or even hundreds of computers. Now, 100 megabits per second these days is kind of small now. You know, It may be sufficient to knock off some websites offline. It's a relatively small amount of traffic these days in the world of DDoS. Like modern era. If this was like in 2000, 100 megabits per second, a botnet or a network of 100 computers, that would be a big deal, you know? So in order to increase your attack's volume, you can try to add more compromised machines to your botnet. Again, adding computers. However, that's becoming increasingly more difficult. There are ways, however, to amplify your 100 megabit per second and make it into something like worthwhile. Now, last week on Twitch, someone here, I know a bunch of people was asking, can you abuse ping? Can you use ping to conduct a distributed denial of service attack? And the answer is yes. And this is what I'm going to get into now. Now, back in the late 90s, early 2000s, using ping to conduct a distributed denial of service attack was all the rage. And it was the attack that took down the White House website. The original amplification attack was better known as the Smurf attack. Yes, that is one of the Smurfs. 80s cartoons still rock up to this day. So here's what a Smurf attack is. So a Smurf attack involves an attacker sending ping requests to the network broadcast address of a router to relay to all the ICMP to all devices behind the router. But this is the key point right here. The key point is when the attacker sends out ping requests, the attacker spoofs the source IP address, the source of the ping request, to be the IP address of the intended victim. Now remember, I said this last week, you cannot ping a port. You absolutely cannot ping a port because ping works on layer 3 of the OSI model. Ping only has the concept of source and destination IP addresses, that's it. No ports, no nothing else. So therefore, ping also does not have the idea of handshake because there's no flags. That's in the TCP layer, which is in layer 4 of the OSI model. Wait, let me just say this again. Ping or ICMP is layer 3 of the OSI, the network layer of the OSI model, not layer 4. I hope I said that correct. I have to look back at the video. Anyway, so ping, you can't ping a port. There's no handshaking. The destination has no way of verifying if source IP addresses is legitimate or not. Okay, so all those devices then respond back to the ping, but back to the spoof source IP. The attacker is then able to amplify the attack by a multiple of how many devices are behind the router. So here's a very nice diagram. So imagine here's your attacker and here's your victim. Your victim has the IP address of 9.9.9.9. Again, the victim has the IP address of 9.9.9.9. So what the attacker does, and imagine all these 5 devices here are all, part of the botnet or compromised devices. So the attacker will send a ping to each one of these 5 devices, okay, at their respective IP addresses, but will say the source IP address of this ping is from the victim 9.9.9.9. So what ends up happening is the device was like, oh, okay, I received a ping from 9.9.9.9. I'm going to send a reply back to 9.9.9.9. They're all confused. It's like, okay, I got a ping from 9.9.9.9. I'm going to send up a reply back. And so what ends up happening is you have a whole bunch of devices actually going to be sending ping replies back to 9.9.9.9, and the victim is going to be like, no, what the hell is going on? And the victim gets overwhelmed with traffic. Okay? So if you have, let's say, 15 to 20 devices, then the victim is going to get 15 to 20 replies, and it will take down the victim very quickly, even quicker. Now here's the thing. Smurf attacks are largely a thing of the past. Because people have abused ping so much in the past, okay, routers, modern routers, devices, hardware, no longer, a lot of these devices no longer respond to ping. They close it off. However, while that avenue is now closed off, the general idea is still very much alive up to this day. Now you have to ask yourself, is there another protocol that you can use where there's no handshaking and that you can spoof the source IP address? And the answer is absolutely. Well, it can't be anything TCP, so it can't be HTTP, SSH, HTTPS, any of the email protocol. You know what doesn't use a handshake is UDP. UDP has no handshake. And what do we use every day that uses UDP? Well, one idea is domain name servers, DNS, the yellow pages or the telephone book of the internet. Believe it or not, DNS does not use any handshaking at all. It's fire and forget. So here it is, DNS amplification. There are two criteria for a good amplification attack vector. Number one, the query can be set with a spoof source IP address by a protocol like ping or UDP that does not require handshake. And here's the other one, is that the response to the query is significantly larger than the query itself. DNS is a core ubiquitous internet platform that meets these criteria. So DNS queries are typically transmitted by way of UDP, meaning like ICMP or ping queries used in a Smurf attack, they fire and forget. So now I'm opening up my terminal right now. I'm going to clear the screen. So what is one, does anyone here know how to, have anyone ever done a DNS query? DNS query on command line? Does anyone know the command? Anyone know the, what do you use for DNS query, DNS lookups? Dig. Kaban. I like Kaban's answer. Okay, so how many letters is dig? 3 letters. Come on, what's your favorite domain? Give me your favorite domain name. Or your favorite website. Oh, shoot. Yeah, okay. Yeah. So you can't put any domains or URLs in the Twitch. Okay, dig or NS lookup. So believe it or not, dig or NS lookup, both will work. They'll probably give you back the same result. But the winner goes to dig because it has 3 characters in the input, not 8. So let's go to dig twitch.tv. Let's find out, okay, the input domain to dig is twitch.tv, and we're going to get back a result that's going to show what are the IP addresses of Twitch. There you go. So how many characters are in the input here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 characters. Character count. Care count. So let's do a care count. Dig at twitch.tv, only 13 characters. So the input is 13 characters. But the output is this mess right here. How many characters is this? You have 13 characters as your input, but your output is 568. What's 568 divided by 13? That's like a 43 times amplification. That's pretty damn good. That's a pretty good payout. You got 13 characters and you get, think of it as like $13 and I make $568 with that. Hey, not bad. And that's the idea. So going back here, so for example, if you send any tiny query, then here it is, dig, and you get back a gigantic response. Now remember, imagine you can spoof the source IP address of the dig query, and that source IP address is a victim. You send all this crap back to the victim, kaboom. That is a 64-byte query that results in a 3,223-byte response. In other words, an attacker is able to achieve a 50 times amplification over whatever traffic that they can initiate an open DNS resolver to. Of course, they also talk about DNSSEC. I don't want to talk about that. Oh, ESPN.com. Hey, Tonics, you haven't been monitoring the NBA trade deadline, have you? Yeah. So here it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 characters, and you get all this junk back. That's a huge amplification. Okay? So now, you may be wondering, okay, I get the idea now. I get the idea. Is there a way, you may be wondering, is there a way to spoof or to modify the source IP address of packets? The short answer is, yes, you can. You can't use tools like dig or NSLOOKUP though. You have to do it programmatically. In this case, we're going to use Python. And we're going to use a very famous Python package that does a lot of packet manipulation for us, and that is called Scapy. Some people call it Scapy. I call it Scapy. Some people call it Scapy. I call it Scapy. And I know Tonics and we worked on this during the summer. Fun time. Tonics, how are you, man? Thanks for tuning in for today. Yes. So, now I'm going to show you how you can, set the source IP address of a packet to be whatever you want. While ideally, the source IP address of anything that does not include a handshake, such as ping or DNS. And I'm sure you also may be wondering as well, can you do DNS amplification DDoS programmatically using Python? We're going to show you the code as well too. We're going to show you that code on how to do that. So now, it is my pleasure now to introduce to you to Scapy. So what is Scapy or Scapy? Now the Wikipedia is a packet manipulation tool for computer networks. It can forge or decode packets, send them over the wire, capture them, and match requests and replies. You can use Scapy to do tasks like unit testing attacks and network discovery. And again, I have to say this for another Twitch stream, any tool can be used for good and bad. The official website of Scapy is scapy.net. Oh yes. Here it is. Alright, Scapy.net. What is Scapy? It's a powerful interactive packet manipulation library. The documentation is here. Now the documentation, a lot of people have complained over the years that it could be a lot better because it's hard to find things. I just want to give you a warning. I find that generally true. And when we were doing a training on machine learning and Scapy last summer, actually with DEF CON and the Packet Hacking Village, oh man, there were quite a bit of gripes. Okay? So actually we'll show you, okay, how this is like a really brief tutorial on how to use Scapy. Now, and there's a lot of introduction here, but what I want to do is want to show you how you actually get set up and using Scapy. Now I'm on my Mac, okay? So what I'm going to do is, you can see on my desktop right now, I have a folder called Twitch_demo. I'm going to blow everything away and start over. So I'm going to do an RM-RF start. Don't try this at home. Okay, so now my desktop is completely empty. Now, the first thing I want to do on, my Mac is I actually want to make sure you install the latest version of Python. So I use Homebrew and just brew install Python. Why is that? Why do I want to install Python? Because you want to be using Python, at least Python 3. Any of the tools that is installed with Mac OS is outdated. Therefore, you always want to be, installing and using development tools on your own, ideally using Homebrew. The stuff that Apple gives you is always outdated. Okay? Brew install Python, and as you can see, I already got Python installed. On this machine. Now the next thing I want to do now is I'm going to clear the screen on my desk. I'm going to make a directory called Twitch Demo. Okay, so now I'm going to go to CD Twitch Demo. Now the latest version of Python does not allow you to install packages onto your system anymore. What you have to do now is you need to set up something called virtual environment, where think of it as a sandbox within a folder, so you can install whatever software and any Python library or packages that you want. And this is actually great, so it doesn't mess up anything on the system level. I kind of like this change. I like the change where you are now forced to actually create what is called a virtual environment within your project folder. In this case, my project folder is going to be Twitch_demo. And now how you actually set up a virtual environment is when you type in Python. Well, by the way, which Python are we using? Oh no! Oh, which Python 3? Opt Homebrew Python 3. Okay. What version of Python 3 are we using? So it's Python 3 space minus minus version, and yet we're using Python 3.13.2, the latest version of Python. Good. So to set up your virtual environment, you do Python 3 space minus M. I think minus M is for module. VENV for virtual environment. Okay. And I'm going to type in ENV. And it's going to create an ENV folder in my folder Twitch_demo. Okay. So what is Python virtual environment, by the way? What is that? All right. Yep. VMV virtual environment, each with their own independent set of Python. Yeah. Virtual environment is created on top of the existing Python. Okay. All right. And this is a really good site for those of you who want to learn more about virtual environments. It's a really good thing. So think of it this way, a separation of concerns. The next thing is, I'm going to do an ls, you're going to see my env folder. We want to activate the virtual environment. The way you do that is going to be source, and now you have to type in env/bin/activate. And as you can see now, preceding my computer name, you see env in parentheses. That means a virtual environment is being used and is activated. Some of you folks, if you ever work with Anaconda, you'll see the same idea. To deactivate an environment, you say deactivate. You can see that env inside parentheses gone. I just go reactivate the environment by hitting the up arrow a few times and just do source space env/bin/activate again. Now the next step is, okay, we're still in the Twitch_demo folder. Let's install Scapy. So you do pip install Scapy. And it's actually nice and light. There it is. And now Scapy is installed. Okay. Now, Scapy, the library, is now installed in this folder, Twitch_demo. Now, if I actually hit deactivate, watch what happens if I try to run Scapy as a command line thing. Nope, doesn't work. It says Scapy command not found. If I go back to my desktop, clear, and I'm outside, and now pwd, I'm outside of the Twitch_demo folder, and I type Scapy, that's not going to work. What you have to do is go into your working directory, in this case it's Twitch_demo. Activate the virtual environment. Now you type Scapy, bang. Hey, welcome to Scapy. Now, there are two modes that you can use Scapy in. One is called interactive mode or command line mode, which is what we're using right now. The other option is to write a Python program that uses the Scapy library, which is going to be the next thing I will talk about, and also your lab number 4, the fourth lab of this course. Here, welcome. Welcome to Scapy. Now here's what you can do in what you call command line option land. You can do simple tasks, such as, crafting a packet and sending it out. Okay? So what you can do is, okay, assuming that you have some Python knowledge, so what you can do is the following. I'm actually going to open up Wireshark and I'll show you. Okay? So I'm going to open up Wireshark. Here's my Wireshark. And I'm going to capture on EN0 on the Ethernet. Or I can do capture options, enable promiscuous mode on all the interfaces. I'm going to start capturing on my Ethernet because that's what I'm using. Oh boy. And because we're streaming on Twitch by way of hardwire Ethernet, you can see a ton of traffic. But I want to only see ping packets. And yep, hell on wheels, this is ICMP. Yep, this is the beers on the wall thing again. I found out that could be my light bulb. Now, okay, I only want to see ping packets going to my intended target is going to be 192. I have a server at 192.168.1.18 on my home computer, so I'm only going to see ping packets going to 192.168.1.18. All right. So what I'm going to do now, well, I will need Visual Studio Code a little bit later. I'm going to create something called a packet. And the packet is going to have, the first thing is going to be an IP. I'm going to set the IP layer of the packet. So this is where you can set the source and destination IP address. By default, you don't need to set the source IP address. Keep that in mind. But I'm going to set the destination to my intended target, which I told you I was going to say is going to be 192.168.1.18. Okay? So now I'm not going to hit the enter key yet. So this packet that we're going to create is going to have the IP address. The source is going to be whatever this is on my computer. And the destination is going to be 192.168.1.18. And this is a ping packet. And the way you actually be very specific on on protocols and applications is to use a slash. And because this is a ping packet, all I need to do is going to type ICMP all in caps and then close paren. And now I'm going to hit the enter key. So now I just created a ping packet that has a destination going to 192.168.1.18. Now, there is a function in Scapy that will allow you to actually show all the details of a packet. And you can do packet.show as a function. And let's see this now what happened. Aha, here we go. So this packet is an ICMP packet, and you can see the breakdown. Okay? Version 4, time to live, the length, the IP flag, the time to live, and you can see that the source IP address on my computer right now is 192.168.1.237, and the destination is 192.168.1.18. Okay, and this is an ICMP echo request. Okay, now I didn't send this packet out yet. I just created a packet. To send out a packet, you can do one of many options. One of them is just use a function called send packet. Watch what's going to happen now when I hit the enter key. And keep an eye on the Wireshark table. Sent one packet. Take a look. You see the echo and the reply. I mean the request and the reply. My machine, I sent 192.168.1.237. The destination is 192.168.1.18. Now you can also see that I did get a reply back from 192.168.1.18. There you go. Cool. Okay. Wait a minute. This is nice, but how do you actually set the source IP address to be whatever you want? Now what you can do is I'm going to create another packet. I'm going to rewrite the packet variable IP, and in this case, for the IP's layer, I'm going to set both the source and the destination IP address. The source is going to be, SRC is going to be inside single quote or double quote. I'm going to do 1.1.1.1, single quote, comma, DST equals 192.168.1.18 again. And this is going to be a ping packet, because if it's a ping packet, that means you can set the source IP address to be whatever you want. Now watch what happens when I do a send a packet out. Watch what happens. Bam. Source IP address is 1.1.1.1, which is the resolver for the DNS resolver for Cloudflare. Destination is 192.168.1.18. It sent a request, but there's no response found. That's absolutely correct behavior, because 192.168.1.18 should have sent a reply to 1.1.1.1 on 192.168.1.18 sent. I can't see that. Okay? So this works out as intended. So yes, this will actually shows you, okay, the ping went through, no problem. I just can't see the reply for very good reasons. But this illustrates, hey, I can set the IP address of the source to be whatever I want. Not bad at all. Does that rewrite the packet you originally wrote? Yes, I completely, no. It's like, Mammy, it completely overwrote the packet. No, completely overwrite it. No, completely overwrite it. Brand new. Okay? Completely overwrote it. Or does it store that packet separately? Not separately. No, not separately at all. Completely overwrite. Complete overwrite. Good question. Complete overwrite. Okay. So you can do all sorts of little tasks, such as this nice demonstration where you can spoof the source IP address of a packet to be whatever you want, a non-TCP packet. There's a documentation, is scapy.readthedocs.io. There's like demo, learning Python, so like this is a lot. I already did the installation for you. Now the other thing that you can do with Scapy, I don't need Wireshark anymore. I can stop and quit without saving. Right now, okay, the problem with command line is, using the Scapy command line, is you can do like one or two tasks. But what happens if you want to write a Python program? A full Python program that uses Scapy. You can do that too. I'm going to quit out of here. I'm going to quit out of the command line. Say exit. The interactive console, I'm exiting. I'm going to clear the screen now. But notice now I'm back in my folder in the command line. So now what happens if we write a program that uses the Scapy library? And that is, of course, your lab number 4 for this course. You go to cs116.org. Remember in lab number 2, the packet sleuth? Your job was, what was packet sleuth? You basically just used Wireshark for the whole lab. Lab number 2 was cut and dry. It's using Wireshark. Okay, you're analyzing PCAPs using Wireshark. But what if now you write a program in Python and Scapy that is essentially Wireshark? Oh, what if you write a program that actually rips out credentials out of the PCAP files in this lab? What if you did that? And that is the whole point of lab number 4, the incident alarm. The incident alarm, and what you're going to do is you're basically going to write a small version of Wireshark With this program that you're going to write in Python will detect fin scan, no scan, Christmas tree scan, the stealthy scan, username and password set in a clear by way of basic HTTP auth, FTP, and IMAP, NICTO scanning, and someone scanning for things like SMB, RDP, VNC. That is lab number 4. And yes, we're going to use Python and Scapy to actually to do this lab. Here's the good news for you. The good news is I have already written a base case for you. I have actually given you a starter code for this lab. This is what is called a working alarm.py. This is working code. Okay, why is there no reply again? Okay, ICMP is, hold on, ICMP is ping. Yeah, ICMP is Internet Control Message Protocol. ICMP is just ping. Just checks if a computer or a device is up on the network or not. We only had to deal with 2 IP addresses. Okay, so hopefully that answers your question, Tundra. Why is there no reply again? Because the reply is going to 1.1.1.1. It's not going to my computer at 192.168.1.237. Remember that. Okay, what if you do everything you're currently doing, but not in, oh, you can do, okay, so SAS gas, you'll be okay with that. If you can do everything, but not in ENV, you can do that, but, there's nothing wrong with it, but the problem is if you're dealing with multiple versions of Scapy, multiple versions of Python, that becomes an issue. I've heard a story about someone writing the address of the recipient as a sender on an envelope without a stamp. Without the stamp, at the post office have to return the mail to the sender. Yeah, that's a good story. Yes. Yeah. Who was the actual? Yeah, writing the address of it as a sender without the. Okay. So I'm going to go back to this example here. And what I'm going to do is I'm going to copy all, how many lines? 33 lines. Yay. Going to Visual Studio Code. Yeah, there we go. I'm going to save, this, save as. I'm going to save this as alarm.py in my desktop on the Twitch demo. Yeah. Now I have alarm.py. Can you ping a laptop that has no battery? Wait a minute, hold on. That's a trick question. Does a laptop actually, is a laptop powered on? I used to run a laptop with no battery, but it was always like connected to the outlet. Yeah, I had a MacBook that would like that, but is a laptop actually connected and turned on by way of the adapter, the power? I did that was my setup back in the early 2010s. Yeah, if it's dead, nah. No, the computer actually, the laptop has to be on. No, it has to be like turned on and connected to the internet, to the network. Okay, so now I have more alarm.py. And here it is. So this is working starter code for lab number 4. And now, whoops, let me show you in alarm.py earlier. You can look at the header from scapy.all, import all. So it's going to load up the Scapy library. Now to run this alarm, the best thing that you can do, that you should do, well, let's see if this works, is do python 3 alarm.py. Sniffing on ETH0. Sorry, can't read network traffic. Are you rude? This is correct behavior. This is absolutely correct behavior. Because how the starter code actually works, by default, it's going to assume that your network interface is ETH0. We're not using ETH0 on the Mac, so that's not going to work. And we're trying to sniff network traffic. Well, we're not doing what you need to be sudo in order to do that. So that isn't going to work either. So if you run Python 3 and then on the base alarm that I provide, this is correct behavior. Okay, this is absolutely correct behavior. Now, let's not do this. Instead, ideally what you want to do is load in PCAPs into the alarm. So what we're going to do is I'm going to download the PCAPs that we use for lab number 2. So I'm going to do set1.pcap, and I'm going to do set2.pcap as well. Okay. So now, as you can see, I have in the folder the alarm, set1.pcap from lab number 2, set2.pcap from lab number 2. Now let's take a look at what's going on in the source code. Do not modify the code below. This is all the helper and the command line argument stuff. Whatever you're doing, whether you're reading in a PCAP file or if you're trying to sniff a network, each and every packet will go into one function, packet callback. The packet callback function is run for each and every packet in a PCAP file or on the network. Okay, so every single packet will go to this callback function, go into this function. Right now, okay, what we can do is what the base code is. If the packet has the layer TCP, okay, and the destination port is 80, it's going to print out HTTP web traffic is detected. That's all the starter code is doing right now. The only thing that you need to do for the 4th lab is to modify packet callback. Do not touch anything here. The only thing you need to do for the 4th lab is just modify packet callback. It's to modify this function. And yes, you can delete this. So I'll show you what happens. Now, I'm going to clear the screen, do an ls. So I'm going to go to Python 3, alarm.py, space. I'm going to read in set1.pcap. I'm going to hit the enter key. Reading PCAP file, set1.pcap on, there's no result. And that makes sense because set1.pcap was entirely FTP. Really? Yes. So let's do another case. So as I do else if packets of tcp.dport equals 21, then I just print out FTP traffic detected, or FTP packet detected. Okay, save it. Now if I hit the up arrow, go back to my as previous command. Now if I reload, if I run this again, get different result. FTP packet is detected. Cool. Clear the screen. What if I try to run Scapy on set2.pcap? Set2 pcap from lab number 2 should be entirely HTTP. Yep, there it is. Okay. Cool. Yeah. Hey. What if I did this? Okay. Instead of FTP packet is detected, what if I do packet.show? So this should actually print out all the TCP packets and set1.pcap. Boom. You can take a look. Wow. This is how a TCP packet looks under the hood in Scapy. The Ethernet, which is layer 2 of the OSI model, layer 3, layer 4. Yeah. Can you get the data? Yep. You're going to see the data stuff here. It's in a layer called raw, or the payload. You can see the quit here. Yep, look at that. you can see the text. So if you're using, let's say, if this was uh, plain text email, you'll see pieces of the email in the load in the load um, attribute or the raw layer. Yeah, you can. Yep, there you go. Yeah, packet callback. Okay, packet callback is used when we send a packet, or when it's on. Or packet callback is used when it's given a set. No. Packet callback. Yeah, I can show you. Packet callback is run for each and every packet in a PCAP file. Yeah, anytime for one single packet, every single packet goes into packet callback. So I'm just going to open up Wireshark here. I'm going to open up set1.pcap. And yeah, I'm going to open up which is 5 megabytes. So yes, in this set1.pcap file, there are, how many packets are there? 1,678. So for each and every one of these packets, all 1,678 packets will go into packet callback. So think of it this way, packet callback is called 1,678 times. So yes, so it's working with only PCAP files in this example, yes. This tool captures packet from the network. Yes, so B.S. Wilson is correct. This tool can also capture packets from the network. We're not dealing with that. You can play around with it if you want. It works, but yeah, it can also read and import PCAP files, which is what you're doing for the most part for the lab. Yeah. Okay. There's so many cool things that you can do with Python and Scapy. So now, you don't need to hear it from me. I'm going to quit this thing. So now you got the starter for lab number 4. Yeah. So what if you want to do Scapy and Python for more sinister things, such as taking down the internet? And that, don't need this anymore. You already have that. I can quit out of here. Maybe you hear it from the expert himself. Maybe it's time to turn it over to a friend of ours, John Hammond, who's actually going to show you how to take down the internet using Python and Scapy. And he did this presentation for us at the Packet Hacking Village in 2020. And little did I know at that time that this talk would still be relevant even up to this day. So I am now going to turn it over.
Alrighty, hello everyone.
John.
Welcome. Thank you for tuning in. I appreciate you being here. This is a talk and presentation titled Take Down the Internet with Scapy. I'm presenting this as part of DEF CON 28 or DEF CON Safe Mode, and I'm here at the Packet Hacking Village. So let's dive into the presentation, but before we do, I've got to say this. I've said it before, I'm about to say it now, and I'm certainly going to say it again many, many times throughout the presentation. Thank you. Thank you for being here. Honestly, seriously, I know things are a little crazy and weird and not how we're used to them being at DEF CON, but thank you so much for being here. Thank you for tuning into this talk. Thank you for being a part of all this. I usually say this at the end, and I'm certainly going to, but now especially, I think it's really important. Just thank you. Thanks for being here. I really, really appreciate it. Okay. So the classic disclaimer, right? The start of every talk, it's just how it's got to start. These are my words, not my employers. I don't represent them. I'm not speaking for them, etc. This is stuff that I wanted to bring to you, me personally. Other disclaimer, don't or do try this at home, right? Anything that we talk about, anything that I showcase here, obviously it's a talk titled Take Down the Internet. Don't actually do that, or maybe do it at maybe your own small scale lab environment, etc. You can tinker with it and explore with it, but don't actually take down the internet, right? Cool. Next, your mileage may vary. I bring this up with everything that I kind of try and showcase. Look, I'm talking about it and I'm showing it to you. Maybe you'll have different results. Maybe something will work differently or strangely in the way that you do it if you do this sort of thing. I can't promise, and I don't mean to make this any written in stone gospel or anything. The stuff that comes out of this talk, it might be different for you, and your mileage may vary. Okay, last bit. We're the good guys here, right? We talk about security. We talk about cybersecurity. We break things for the sake of making them better. We hack for good. And I want you to do the same. The stuff that we're going to talk about and showcase in this presentation, maybe it's a little bit on the different side of the fence. I want to reiterate to you and kind of enforce it. Hey, hack for good. Okay, obligatory introduction, right? Who is this guy talking at you? Hello, my name is John Hammond. I'll try and run through this quickly because I know no one cares, not even me. I used to just do some stuff with the Department of Defense Cyber Crime Center and their Cyber Training Academy, and I also work with the Defense Threat Reduction Agency as a kind of a red team cyber operator. Right now, I'm working as a senior security researcher over at Huntress Labs. Again, not speaking for them. These are my words, not theirs. And in my free time, I like to play a little bit of Capture the Flag. I like to develop and create and host Capture the Flag events or competitions or exercises and training sets to try and make people better, to try and improve everyone's cybersecurity skill. On that same coin, I do produce some cheesy YouTube videos. I publish and showcase some Capture the Flag write-ups or programming tutorials, video guides, stuff like that. But that's all nerdy stuff that you don't really have to care about. Let's talk about what we're going to talk about. Kind of meta, right? So here's the agenda, the roadmap, the outline for our discussion. First, we'll lay the groundwork. We'll put down a little bit of a background, really set the scene for what we're going to be discussing. I'm going to be talking a little bit about Python, right? Python's kind of my weapon of choice, but we needed to make a distinction between Python 2 versus Python 3 and what we'll kind of be using as our vessel throughout this talk. Then I'm going to introduce Scapy, one really, really cool Python module or library that you can pull into your Python source code, use with your projects, your other scripts, whatever you're working on to do really, really cool low-level stuff with network packets, with the stuff that you would find in PCAPs if you were taking a look at it in Wireshark or TCP dump, etc. We're going to do that with Scapy inside of Python. So we'll talk about how to install it, some documentation, syntax, and use cases, etc. Then we'll get into the real meat of the conversation. We'll talk about different attacks that we could perform, and we'll kind of zoom in or zoom out as appropriate on some of these different things. The ping of death, the SYN flood, DNS attacks, BGP, etc. I do want to showcase a couple of IRL or in real life cases, right? Stuff that we've really seen out in the real. Typing in commands and getting that returned back to you, like interactive shell. Or you could work with it inside of a script and have Python just import Scapy as a whole module. And you can access all of the code, the functions, the variables, all of that functionality that Scapy offers inside of your Python scripts, inside of Python. Now, this is crazy cool because we can work with TCP packets, UDP packets, any other network stuff, maybe CAN bus protocols or Bluetooth. There's so much more, and we could dive into some of the documentation for Scapy. I always want to point people to the real documentation because that's where the real stuff is, right? I'm not going to be the expert, sorry. I don't think you would call yourself the expert, and I'm not saying that to be mean. I'm just trying to say the source code is the truth, right? Documentation is the real accurate stuff. That's what's really there, really built in, and the official source, it's what's good to go to when you need help or you're trying to learn something new. Obviously, there's a man page for the command if you wanted to fire that up. Obviously, they've got an online web presence. You can check them out at scapy.net. And they have official documentation over at readthedocs.io. And of course, a GitHub page. So you can go take a look at the source code. It's open source. It's awesome. It's all Python, good stuff. The website is actually fantastic. They have a page over there called Awesome Scapy. And that will showcase other tools, exploits, and some sample code to use. And it's really, really cool. They have some good stuff on Wi-Fi, like mapping and tracking Wi-Fi networks through 802.11, making a roaming access point, performing some man-in-the-middle attacks, some Tor, onion router protocol stuff, tons and tons of great stuff, even CVEs and exploits for common attacks, or stuff from Crack, the attack against WPA2. Super duper cool. Really recommend you go check that out. Okay, now let's talk about the basic syntax of Scapy, because if we want to use it, we have to know how to. I say that Scapy is Pythonic in that the syntax that it uses when you're working with the module, you're working with Python objects, right? The same way most everything in Python really is that you're interacting and working with an object that has methods and properties and all these attributes and things you could work with that are really under the hood, right? Functions and variables, just with a kind of a different decorated name. But being object-oriented means we can do some kind of nifty things with it. Maybe not all the time. I'm not trying to say OOP is the way, but it's nice to have that kind of built into the language when necessary. So you can see I'm working in like a little bit of a script here, right? I've got a shebang line set up. I'm going to work with Python 3 as my interpreter. And I'm going to use that from scapy.all import everything, or the asterisk, the star, the wildcard, to pull in everything that Scapy module has into my current namespace so I can interact with it and I can work with it through Python. So here I'm going to create an object or a little variable, ping equals, and the IP, this big class name, right? You can see the capital letters there. That's going to return a Scapy object, and it's going to be a packet, and I can define how that packet looks. Maybe I don't want to use an IP, or maybe it's that specific header for that protocol. I could zoom in on other things between TCP, UDP, HTTP, or anything else. And Scapy already has support for all those crazy cool protocols and layers, and you could just pull them in and work with them. Or if you really wanted to, you could go do a little deep dive, get in the internals, and build your own. So note inside here, I'm creating this IP object and I'm passing in a keyword argument. I'm saying DST, or the destination IP address. I've simply set that to a string, 192.168.1.1. And I've had a little division symbol, or that forward slash, which looks weird, right? Because we're not dividing these objects, but I'm using that syntax, and that is the syntax that Scapy uses to actually add layers in or kind of build them into that packet that we're crafting. So now I'm going to say this is simply going to be an ICMP packet or ping packet, right? I've assigned that to that ping variable or the object, and I'm just going to print that out on the screen. If I were to run that script, check out down below. Now I have that kind of B prefix to note that this is a binary string, or I'm just including real raw bytes here. And that \x, the \x everything, all those are the bytes to this packet that I've just formulated and created in a super duper simple way, right? It literally took one line of Python code, and now I have a ping packet. And I could do this. I could send this packet. I could receive the information that comes back, maybe a little echo, a request, reply ping. That's very, very cool. All in a script, all automated and extensible, whatever way that I want, and super duper short, right? One line of that Python code, easy to read, easy to write. Obviously, Scapy is abundant, and there are more examples of this sort of thing on their website and their documentation. And that's really, really why I'm pointing you all towards it, because that's where the good stuff is. We're going to cover some cool stuff in the talk, but if you want to go deeper, learn more, do some more research, I'd recommend, hey, go check out that documentation. Okay, last slide on Scapy, I promise, then I'll shut up about it and we can move on. I'm not trying to sound like an evangelist here, but I am trying to show to you all of the cool things that Scapy can do. Obviously, in this last slide, we just looked at a super duper small, minuscule example of one thing that Scapy could do. What we could do with that packet, or with many other packets, is put that together into a PCAP file, write it out to a packet capture archive. Or we could read in a packet capture archive or a PCAP file, read through it, loop through it, do interesting things with it. Or we could sniff and listen and actually capture live packets and dissect them or forge new ones, etc. With filters, import and exports, create graphs, reports, tables, etc., etc. And obviously, all of those specific different protocols that we would want to work with, we can. And then maybe we could turn it into more of the offensive side. We could probe or scan or attack networks, fuzz specific aspects of a protocol, or send malformed packets. And we could do crazy tricks like, ARP poisoning, or do some specific kinds of scans, etc., etc. The benefit behind all of this, and this is what makes it so awesome, is that it can all be automated and you can write it and you have that fine-tuned control all within Python. You have the entire arsenal of the Python language and libraries, modules, other tools that you can use and pull into it. So that's super duper cool. Now let's get into the good stuff. Let's get into the really cool attacks that could potentially take down the internet, right? So we'll start small, we'll start with some simple things, and then we'll slowly kind of zoom in onto more complex stuff. But just to kind of whet your appetite, let's start with the ping of death. Interesting name, right? So the ping of death attack is a denial of service attack where the attacker will stop a machine by sending a large ping packet. So large, in fact, that the machine can't handle it. It'll choke. There's so much data in that packet that the machine doesn't know what to do with it, and it'll freeze up or just fall over or crash. We talked about ping packets in the previous example, or that script and source code that I showed you earlier, when we were looking at that ICMP protocol, or the Internet Control Message Protocol. So typically, ping packets are very small, but IPv4 ping packets can be much larger, up to the maximum allowable packet size of 65,535 bytes. Some systems might not be designed to actually handle packets larger than this maximum, and they might be vulnerable to packets at that size, and they're sensitive to it, they'll choke, and they'll fall over. When this large evil packet is sent from the attacker to the victim, the packet becomes fragmented into different segments, each of which will be smaller than the maximum size limit. When the target and victim actually attempts to put these pieces all back together, eventually that total size will exceed that maximum size limit, and maybe a buffer overflow occurs or something goes wrong and that machine can't handle it. It'll freeze, it'll choke, it'll crash. So we're using this example where the ICMP echo or that ping packet could be used for this attack, but really anything that sends an IP datagram that can hold more data or can have this attached information that extends beyond that maximum size could be used for this attack. That could be TCP or UDP or any IPX stuff. Admittedly, the ping of death attack is kind of old and a little outdated, but I think it works as a really cool and simple, quick jumping off point or starting point for us to take a look at some of these evil, nefarious things that we could do with Python and Scapy. So with that said, let's take a look at the source code here. You can see I'm using the send function, which is part of Scapy. We say we've imported everything into our namespace. You could also send just one packet and receive the information back, or send packets inside of a loop. But for just one quick shot, firing the gun, we can use this send function here. We'll create a fragment, as kind of we discussed earlier. Sending fragments that might be rebuilt and reassembled by the victim machine that could potentially cause it to crash and choke. And inside of that, we'll build this ICMP packet just as we've done before in that previous example. However, you can see there at the end, we use another divider or to add in another layer or some more information into this packet. And I just use a simple dummy string. I just use the letter X and I multiply it by this large number. So I have this data payload, this information that I've strapped to this ping packet so that I can send a ping of death that's just a little too big. And maybe that machine is biting off more than it can chew. It'll choke and it'll fall right over. I did mention, though, that this ping of death attack is less common today, right? More so now, you'll see other kinds of attacks that are still this denial of service attack, right? We're being a jerk. We're overwhelming, flooding, and just bogging down the resources on that victim or target. So one of the more common ones you'll see now is perhaps an ICMP or a ping flood. And we can certainly send other kinds of floods. One of the most common ones you might see is a SYN flood. SYN flood is another denial of service or DDoS attack, which will make that server, your victim, unavailable to respond. It'll be just too busy. It'll be bogged down. It'll be hosed because something will be consuming all of the available server resources. We're going to cause that by sending packets with that SYN flag set. So you know TCP packets, right? TCP being the transmission control protocol, which ensures there is a connection in place by using the three-way handshake, right? The client on one side of the conversation will send to the server a packet with the SYN flag set to synchronize or start the conversation and begin requesting communication. The server over on the other end of the conversation will say and respond back with a SYN ACK packet or a packet sent with those flags set. Finally, the client, knowing that the server has responded, that someone actually answered the phone, it will respond once more with an ACK flag set on a packet, or the acknowledgement, okay, someone is listening and we can talk, we can have this conversation. Interesting thing though, on step 2 of that process, or in the middle of the three-way handshake communication, the server, while it sends that SYN ACK packet, it will wait to receive that ACK packet from the client so that it can begin having this conversation. So the attack is simple. We just send a ton of SYN packets where we're just starting all these conversations. We're dialing the phone, but once someone answers, we don't care. We don't respond to them with an ACK packet. So they're overwhelmed, right? The phone keeps ringing. They're going to pick it up and they're going to want to talk to someone, but no one will be there. They're just not having this conversation, but they're still holding the phone and more are ringing. That will hog all the resources. That will cause that target victim to not be able to respond to other legitimate traffic because, okay, hey, they're busy, tied up with other stuff. All those resources are being utilized right now. Because this attack brings that server to the halfway point in the three-way handshake, right? They've started the communication but have not responded to the server's acknowledgement. That means that it's halfway communicated. That's why it's called that half-open attack. Kind of interesting. So let's take a look at the source code, right? Scapy, again, makes this super duper easy. We're performing this attack in, realistically, 2 lines of code that could even be shortened to 1 because, hey, maybe we could abstract out that object that's not necessary for that SYN flood. We could just pass that to the function. So I'm creating the SYN flood object or variable, right? I send in a keyword argument for the destination. Again, just an IP address we'll use. We'll set an ID number for that packet and we'll specify the time to live. These values aren't extremely important for kind of just our discussion, but obviously that next layer certainly is. We create a TCP portion of this packet, and that sport, or S port is how you should read that, for our source port, that's just going to be a random ephemeral port that Scapy will help us generate with that rand short function there. That'll return something that make it look like, okay, we're coming from a different port every time. The D port, or the destination port, will be passed in as a list or a little Python array. We'll just send this over to port 80 HTTP. You could specify this to whatever you wanted to, maybe SSH or anything specifically. Specify a sequence number, specify an acknowledgement number. Again, for this example, those don't really matter all that much, but maybe they could in other scenarios. The window size, and the most important thing here, the flags that are set on this TCP packet. Obviously, I'm just passing in a string here with that capital S, and certainly enough, that stands for SYN, right? The SYN flag has been set on this packet. So we have created one packet that is just a SYN packet. The very, very first step in that TCP three-way handshake. The next line below, we're going to end up using that SR loop function that Scapy makes available to us. And that is going to send and receive packets in a loop. So we will repeatedly, over and over and over again, send this packet. The keyword arguments there, that inter or the interval, we'll send those at 0.3 of a second. We'll retry every 2 seconds if that kind of gets dropped, and we'll have a timeout of 4 seconds. Again, those are a little extraneous, but the point that we're getting across right now is that we are looping a SYN packet being sent over and over and over again. We are flooding that target victim server with this SYN flood attack. In the case of the line of code there, we have an answered and unanswered information that's being stored as a return value of that SR loop. That'll just return a tuple, okay, or a list of what packets actually had a response and what didn't. The point that I'm trying to get across is that just these 2 lines of code are putting together this attack. And it's super duper simple. All you've done is outlined the structure. You've orchestrated this packet, and now you can put it to work. You can weaponize it as a SYN flood. You might notice, though, into the next attack, DNS amplification attacks. A DNS amplification attack is a really interesting technique that abuses the regular functionality of DNS, or the domain name system, to again overwhelm, spam, and flood a target or victim machine. The way that this works is that the attacker actually sends a legitimate regular request to a DNS name server asking for as much information as they can. So their request is a regular kind of small, tiny packet just asking for information, and the domain name server will respond with as much information as possible, and that way you get a much larger packet in response. The trick here is that with this DNS amplification attack, the attacker sets their IP address, the source, back to the actual victim or the target server that they're aiming to overwhelm and choke. You can see this here in the source code, right? We're defining, again, another object or variable to keep track of our packet. We're defining an IP header, but interestingly enough, we supply that SRC keyword value, or the source IP address of the packet that we're going to be formulating. Note, this will act as our victim. This is the target machine that will have the domain name server send back that large request. You can see again our division symbol or the / to add new layers, and we're adding a UDP packet portion, right? We'll set the D port or the destination port to 53, the default port for the domain name system or DNS servers. And what we're going to query from this DNS is anything we'd particularly like. Here, I'll just ask for anything regarding google.com or that domain. You could, of course, ask for any type or any resource record you'd like, an A record, a text record, a CNAME record. Generally, with this attack, you could expect to see the attacker request for any, as in return all of the resource records you could give me. We'll have that packet formulated, stored, and encapsulated in that DNS amp object and variable, and again, we will just send that packet along. The DNS server will respond accordingly. It will give all the information it can, but send it to that source IP address, not our actual attacker. That will flood and overwhelm, choke that target victim server. Obviously, you'd want to have more than one attack or one attacking machine doing this. You could perform this distributed denial of service, right? That DDoS, or send this request multiple times. But I think this attack is really cool and really interesting, right? If you put it in kind of layman's term or a normal human explanation, say you are at the drive-thru ordering some fast food to go or whatever the case may be. Let's say you ask the person or the teller that's chatting with you and taking your order, I want one burger or I want one drink or whatever. Typically, that job of the teller will read back your order, right? So envision this scenario. You as the driver, right? You as the attacker, you say, I want everything on the menu. And then before they can read your order back to you, you drive away and let that next person go ahead and actually hear all that information. So while you just asked for a small, tiny thing and a simple, hey, give me everything you've got, the next person or your target or your victim is going to be read and enumerated and receive all of the information. So maybe, I don't know, what a 1 scale for your packet could respond to a 10 in the response and what that teller will read out to that other person or that individual. Kind of cool. And obviously, another added benefit to this is that the attacker is performing this attack indirectly. They make this request out to an open and accessible DNS resolver, and it will respond and just send that information out to the actual target or victim themselves. The attacker doesn't really leave any fingerprints or a trace on the target. It's not reaching it directly. It is an indirect attack. You can see that here again with that syntax, but as always, Scapy is making this really, really simple and honestly really easy. Okay, now let's talk about our finale attack. I want to discuss BGP abuse. So BGP is the Border Gateway Protocol, and that is the standard routing protocol of the internet today. That means that it's actually telling your computers where these packets are going